This video is going to be for troubleshooting GY6 starting issues. I'm going to show you how to test the CDI module, how to check your ignition coil, and a few other things. All right. You're going to remove the 4 screws that hold this basket in place under the seat. There's one here, it's a 10mm, another one there. Inside here there's one, and over here there's another one. Once we get that out of the way, I'll show you the next steps. Alright, now that the basket's been removed, you have access to the compartment. In order to remove the basket, you have to remove the gas filler cap to slide the basket over it. And in my case, I had a 12-volt accessory socket under the seat, and I had to remove that. Now, the CDI is mounted underneath the plastic. In my case, on the right side, which is right here. That's the location for the CDI. That's your starter solenoid. They're very easy to test. Alright, if your battery's fully charged and the scooter does not turn over, you don't get any cranking, you're going to want to remove this compartment like I did to access the solenoid. And you'll want to put the engine start switch to on, and then you'll want to jump these 2 terminals. You could put a heavy gauge jumper wire across here, or you can get a large blade screwdriver and just short it, and when you do that, the engine should start cranking. If it does start cranking, then the next thing to do is to locate the wire that connects to the solenoid, and you're going to want to feed 12 volts directly to that wire feeding the solenoid, because that's what pulls the solenoid, allowing these contacts to close. So if it does start when you short this, the next step is going to be to take this harness here, which is connected to the solenoid, and you're going to want to put 12 volts directly into the 2 wires feeding the solenoid to see if it clicks. If it clicks and the engine starts, then your problem is not the solenoid, more than likely a bad wire leading to the solenoid, or your alarm system is preventing the scooter from starting. So you could rule out the solenoid very easily. I'm going to point out all the locations of the components in here. On the right side, under the piece of plastic here, you're going to have your CDI. Moving forward, you're going to have your starter solenoid. Now you go lower, right here, where that boot is connected, where I'm pointing to the orange, is the ignition coil. Now onto the carburetor. Left side of the carburetor is the idle enricher that adjusts the idle once the engine warms up. There's a plunger that slowly pulls back, which lowers the idle after the engine is warmed up. Now, going from the carburetor, if you turn to the left side, this is my fuel filter. Now you're on the other side of the scooter where the plastic is. You're going to come down. This valve opens when vacuum in the engine is detected. So if your engine is running, it allows the flow of fuel from the gas tank to flow through this valve into the carburetor. If your engine is not running, then this valve stays closed and fuel can't pass between this line and this line. Alright, on the fuel tank, right back here is your sending unit, which I've had to take out and repair once because my fuel gauge was not working properly in certain spots, so I had to solder new wires onto the fuel sending unit because they were worn down. So that's right under here. There's a ring that you release, but in order to do that, you have to unscrew these 2 bolts to push this locking mechanism out of the way so you can get in here to get it and then pull it out at an angle. So you can get that out if you have to. Now straight down, like I said, here's your ignition coil, there's the carburetor, there's the idle enricher again. Down here is your starter. And that's about it for in here, for electrical components. Now behind the flywheel in here is the stator coil. And then you also have the pickup coil. Alright, and that cable of wire comes out right here on top, and it feeds through this cable heading up to a harness. We're going to be doing some testing with this cable heading up. I'll show you in a minute. Okay, this is the CDI. Just slide it up. Once it's slid up, you can pull it outward this way and let it hang like that. Now this ground wire here, you can see it's heat shrunk and attached to the body. I thought I was having a ground problem once, so all I did was ensure that the ground that goes to the module is definitely grounded. And so that's just an extra thing. You're not going to have that. I added it just to make sure there's no ground problem. Okay, good way to rule out that fuel is not the problem is you're going to go to the intake hose. You're going to squeeze this clamp, and then you're going to pull out this little plug. And what you're going to do is you're going to get a propane torch. You're going to put the propane torch, of course you're not going to light the torch, you're going to put the propane torch, the opening of the torch, right into the hole. And you're going to turn it on for a couple of seconds, and then turn it off, and then shove this plug back in. And then immediately start the engine. If it does turn over, you have a fuel problem, not a spark problem. Okay, this is a simplified diagram here. What you want to do is the first thing we're going to check is to make sure that this switch, which is right here, alright, that switch, you want to make sure, see it's in the run position right now, but you want to make sure when it's in the run position that it's not acting like it's in the stop position. Because if that's the case, you're going to crank and you're not going to get any spark to the ignition coil. So the first test is going to be to make sure that this wire, this terminal, is not grounded when the switch is in the run position. And the wire that is this one right here, the top left, the black, is this wire right here. Alright, so the top left wire is the one we want to check to make sure it's not grounded out. So we're going to release the connector and slide it out. You lift that tab and you just pull it up and out. There, it's out. Okay, now using a digital multimeter on a continuity setting, which this is right now, it's continuity, I touch the two wires together. Here we go. Alright, so the easiest way to test the kill switch, once you unplug the connector from the CDI, we're going to be testing the wire, which is this black one. We're going to put the probe of the DMM right there. The other end of the DMM goes to a good engine ground. You're also going to want to make sure the engine is on. Make sure it's in the on position, and we can start by putting it to run. Now I'm going to touch right here, and right now it should not make a sound when I touch it. Alright, so that's good. Alright, so the switch there is fine in that position. Now I'm going to leave this connected as you see, but I'm going to go to the switch here, and I'm going to slide it over. Alright, pushing it to the left, which is stop, causes that wire right here to go to ground, so that's working perfectly. Now if I push it back, now it's back to engine run, and the wire is no longer grounded out. Now if you do this procedure, remember the key switch has to be on. If after leaving the key switch on that this test still fails and it continues to ground out, the problem may not only be the switch. The problem may not be only that switch. You could also have a problem with the key switch, because this key switch also has a switch in it, works in conjunction with this switch. So if this switch grounds out in both directions, on and off, then either the switch is faulty on the steering column or your key switch is faulty. Alright, so once you rule out whether the key switch is a problem, then the next thing you want to do is check the red wire. Now the red wire is where the CDI gets the power from. Alright, so this is alternating current that shoots out. and it converts it to DC in the CDI. So you're going to leave the wire connected to ground, and we're going to put the multimeter on a setting, let's say 2K, 2000 ohms, and we're just going to touch this wire. We're touching it now to the red that leads to the stator coil behind the flywheel. This is 530 ohms. So mine works fine, so you'll know that yours should be within a range of 430 and 630. You should be good on the red wire heading into the stator coil. We're going to remove this connector now. Just pull this little tab outward, and I can just go like that, and that's out. The best way to test the CDI is actually to rule out everything else that's a problem here. So now that we unplug this connector, as you can see in the schematic here, we got a red, a black, and a green, and actually two greens. So we're concerned about the top green. We want to make sure it's definitely grounded. We're going to check to make sure this green wire is definitely grounded. So we're going to put this back to the continuity setting, and when you touch ground, this will come on, see? Alright, so now what we're going to do is we're going to take this top right wire, which is this one right here, take the top right that was in the connector and just touch it. You should get a tone. Alright, so we're good between there and ground. So you know that that's grounded out, so that's good. The next thing you want to check is the pickup coil resistance. That's mounted outside the flywheel. It's a little black little plastic coated module. I had one go bad a while back, and I ended up rebuilding it myself because where I live you can't get them, and to order things takes a very long time to get them here. So I did fix that once, but we're going to check that right now, and that's with this red wire. So to check that, we're going to put the meter to 200 ohms. We're going to leave that grounded. Okay, about 163. They can run between 140 and 185, 190. So long as you're in that range, you're good on that wire. Now the next thing we're going to test is the primary, which is the low voltage end, and then we'll check the secondary. But we'll do the primary first because we're working with the CDI. We'll do the secondary in a few minutes. Alright, so now I'm going to do a test. Now before I do that, you could check directly from the ignition coil terminals, alright, which is what you would do if you don't get a reading here. But I'm going to check from here, which is going to add a little bit of resistance to my reading because I'm going through a lot more wire and then through the whole chassis. And I can show you right now, because if I short the two connections out right now, you see it will go down to 0. All right. So now what I'm going to do is just show you when I touch ground, because this is on ground here. This wire, this end of the probe is to ground. I'll touch it to this part of the ground. The extra wire adds around 0.8 ohms to the reading. So whatever my reading is going to be from this connector, I'm going to deduct 0.8. So I'm going to touch it to the black and yellow, and I get a reading of, let it stabilize. I get a reading of 2.8, which is really 2 ohms if I deduct the resistance from the wires. So if I was to check this coil from the back of the coil, right on the coil, it would give me around 1.9 to maybe 2 ohms. Which is perfect. You want to be under 3 ohms, but you want to be over like 0.8. Right, now we established that the ignition coil on the primary side tests okay. And we checked each one of these wires, the ground, we checked the one to the coil, we checked the one to the pickup, and we checked the one to the key switch, and the one heading to the stator for the power to the CDI. So these are all good. Okay, for these tests now, because I'll be doing some cranking without the engine starting, I just have my battery charger hooked up just to maintain the charge of the battery so I don't bring it down. Okay, for the next test, we're going to be testing the red wire going to the stator coil, which is this one right here. Alright, we want to see what the voltage reads in alternating current while the stop switch is on and the engine is cranking. So I have this needle into the harness to the red wire, hooked up to my red probe. I have the ground on the black probe. The ground is on the black probe. And I'm going to crank now, and we're going to see what kind of a reading I get. I'll crank the engine to get an idea what the reading is when the engine doesn't start on a known good red wire coming from a stator coil. Make sure the meter is set for 200 volts. And here we go. 75 volts. So I'm getting around 75 volts cranking. So that's a good reading. So between, like, I guess between 65 and maybe 90. So if you're getting a reading between 65 and 90 volts AC when this is unplugged and you probe the wire like this while cranking the engine with the stop switch on, then that part of the stator coil is good. So you're getting power, no problem going into the CDI, and we know the stop switch works. So this whole part of the circuit can be ruled out, but it doesn't rule out the CDI as bad yet. Alright, so we're increasing the likelihood right now that the CDI is faulty if we can rule out the coil is good. We're going to do one more test on this, and that's going to be the pickup coil wire. We're going to rule out that this is a problem. We know the ground is good, and we know the primary resistance of the coil is good. We're going to now test to make sure that the pickup coil wire produces the right amount of voltage while we crank the engine. Same, you could lower this setting now down to like 2 volts AC. We're going to probe the red wire right here. Okay, we're connected to the red wire. What we're going to do now is we're going to crank the engine. The stop switch is on to prevent the engine from turning over. And we're going to crank it and get a reading out of this pickup coil. 0.25. Alright, so 0.25 on this wire is excellent. Usually it's between like 0.16 in my range. So if you get a really low reading like 0.0 something, you could have a problem. If your engine cranks faster than mine, you can have a higher reading than mine. If it cranks slower, you can have a little lower reading. But as long as you have a reading on this wire between, say, 0.12 and 0.25, or maybe 0.27, you're in good shape. So right now we know that this pickup coil wire is perfect. There's no problems there. The ground wire is perfect. The power line coming in from the stator coil is fine. The kill switch tests perfect. And we verified the right amount of resistance in the coil here. So as of now, if your scooter doesn't start and you did the fuel test with the propane, more than likely the CDI is bad. We could make that almost certain in a minute when I rule out the high voltage side of the... So far it's looking extremely likely, if your scooter isn't starting with these kind of readings, that the CDI is indeed faulty. But to make sure, the last test here, besides the spark plug itself, is you want to check to make sure the secondary side, which is the high voltage side, because we know all these wires are fine here now, you want to make sure that the secondary side has the right amount of resistance. Inside the ignition coil, I'm going to explain this part rather than pull mine apart. It's very easy. Inside this coil there's a screw, a sheet metal screw that sticks out in the center. How they do it, they take a spark plug wire and they screw it into the boot with the screw that's in there. The screw makes contact with the center conductor of the spark plug wire. The screw is what holds it into the coil tightly, and then a boot slides over. So the two tests you're going to want to do is you're going to want to, I would personally unscrew, because I've seen problems with this connection right here. So you're going to want to unscrew the spark plug wire out of the coil, and then put your multi-tester on a high setting, 10 or 20,000 ohms. And you're going to want to put one probe to the screw inside the coil, make sure it's clean, not rusty, and the other to the ground. You should get a reading between 2 and 4,000 or 4,500. That's a good coil. Then you're going to want to screw the wire back on. Once the wire is screwed back in, you're going to pull the boot off the plug, and you're going to put your digital multimeter probe right into the center of the boot to the metal to make contact, and then the other end is going to go to here. You should have a little higher reading, maybe an extra 2,000 ohms or maybe an extra 1,000. It should be higher because you got the resistance of the wire. If you get an extremely high reading like 10, 20, 30,000 or something like that, it's likely that the wire is faulty and you're not getting the spark because of the bad wire. Alright, so now the only thing that leaves left is we checked out the coil, high resistance on one side, low resistance on the primary side. We checked out the wire. It should add a little bit of resistance to your reading from the screw on the coil. So the next thing you're going to want to do is check out your spark plug. You could test this with a digital multimeter, but the only problem is when this heats up, you could check this when it's cold to see if it's okay. But when it heats up, if the electrode in the center of the insulator is cracked like a hairline, when this all expands from the heat, you're going to get a little bit of an opening in the center electrode, which could screw you up. So I'm going to show you how to check this while it's cold. We're going to make sure there's a good connection between the end of the plug where the boot goes on and the tip of the electrode. Not the end where the spark jumps, the electrode itself. And that should be a very, very low reading. Right now my DMM is set to 200 ohms, the lowest setting, and I'm going to get a reading right now. Alright, I'm getting a reading of roughly 0.2 ohms to 0.3 ohms. Alright? So you want to get a low reading between there and there. That confirms that the current, the spark can make it through there. Alright, so for the next test, we check the electrode in the middle, that's fine. The next thing you want to do is you want to use a high setting, 20 megohms. I have a 2000 megohm, but the average person doesn't have a meter like this. They have a 20 or a 10, which is fine. And you have to understand when you're doing this kind of a resistance test, let me hold this with my leg, alright? You have to be careful because just your body will give a reading. See, that's coming up 2 million ohms. So when you do this test, alright, so when you do this test, make sure you use a piece of plastic, hard piece of plastic or a piece of formica, and lay the plug on the plastic. Because if you do it on the ground, if you do this on the ground, you're going to end up getting a reading because of the moisture in the concrete and paper and stuff like that. So do it on a piece of plastic. Then you're going to take one probe and push down. Whoop. Take one probe, push down on that part, and then this probe will go right onto the body. Push down. You should get no reading like I'm getting right now. It's hard for me to show you with the camera because I'm holding both hands are doing this, but you should have no movement on that 20 megohm range. If you do, then that means there's a short between here and there, not allowing the full spark to exit the tip. So this plug is good. The last thing you could do now with the spark plug would be to plug this back into the boot and push the end of this plug, the metal part right here, with a pair of pliers. You would hold the spark plug by the boot and push the metal against the ground of the engine and try cranking and see if there's sparking going on. If there's no sparking going on at all, then without any doubt the CDI is faulty. Because we know the pickup coil's fine. We know the power from the stator's fine. We know your ignition coil's fine. We know the kill switch isn't causing the problem. So it's looking extremely likely that there's nothing else that could be the cause for your scooter not starting besides the CDI. If after doing all these tests and you still don't have spark, then absolutely CDI. If your scooter does have a spark, then that means all this is good. And if you injected propane in here, like I told you to earlier, to rule out fuels being a problem, and it still didn't start even with the spark, then that only leaves that your valves are not set properly, or your engine is not timed properly. It might have jumped time, something happened, but either your timing is off or the valves are not properly set.